There's another pathway to NAD+ production that doesn't get as much attention as vitamin B3, but it might be equally important, especially for older adults. Your body can synthesize NAD+ from scratch using tryptophan, which is an essential amino acid found in protein-rich foods. This pathway is called the de novo pathway, and it represents a completely different route to maintaining NAD+ levels that doesn't rely on getting preformed niacin from your diet. Tryptophan is found in virtually all protein-containing foods, but it's particularly abundant in turkey, chicken, eggs, cheese, fish, tofu, nuts, and seeds. When you eat adequate protein, your body breaks it down into individual amino acids, including tryptophan, which can then be converted through a series of steps into NAD+. This process is less efficient than converting niacin directly into NAD+, but it provides an important backup pathway, especially in situations where niacin intake might be limited. Here's where things get concerning for older adults. Protein deficiency is remarkably common in the elderly population. Studies suggest that anywhere from a quarter to half of older adults aren't consuming enough protein to maintain optimal health. There are multiple reasons for this: reduced appetite, difficulty chewing or swallowing, limited budgets, reduced mobility making shopping difficult, and sometimes just living alone and not feeling motivated to cook. When protein intake drops, tryptophan availability drops, and this could potentially contribute to declining NAD+ production capacity at exactly the time in life when NAD+ levels are already falling due to aging. The protein requirements for older adults are actually higher than for younger adults, not lower. While a young person might do fine with 0.8 grams of protein per kilogram of body weight, older adults likely need closer to 1 to 1.2 grams per kilogram to maintain muscle mass and support metabolic functions. For a 150-pound person, that's roughly 68 to 82 grams of protein per day. That might sound like a lot, but it's achievable with planning. A few ounces of chicken or fish, a couple of eggs, some Greek yogurt, and a handful of nuts throughout the day will get you there. What makes this particularly relevant for brain health is that NAD+ production from tryptophan requires several enzymatic steps, and some of these enzymes decline in activity with age. So not only are many older adults eating less protein, but their ability to efficiently convert that protein into NAD+ may also be compromised. This creates a double hit on NAD+ availability right when the brain needs all the metabolic support it can get. Now, there's a complexity here we need to acknowledge. Tryptophan metabolism is influenced by inflammation. When the immune system is activated, tryptophan gets shunted preferentially down a different pathway that produces immunomodulatory compounds rather than NAD+. This means that chronic low-grade inflammation, which is common in aging and Alzheimer's disease, can effectively hijack tryptophan away from NAD+ production. This is one reason why managing inflammation through diet and lifestyle is such an important part of the overall strategy for supporting brain health. The takeaway here is that adequate protein intake matters for more than just maintaining muscle mass. It's providing essential building blocks that your brain needs to produce NAD+. For older adults, especially those at risk for cognitive decline, ensuring sufficient protein intake should be a priority. This doesn't mean going overboard with protein, but it does mean being mindful that plant-based meals need to include adequate protein sources and that skipping meals or eating very small portions could have metabolic consequences that extend beyond just feeling weak or tired.